Have you ever noticed how many shapes are in the world? I mean, think about it. You've got your circles and wheels and the car and clocks. You got rectangles and televisions and cell phones. You got your triangles, your squares, your trapezoids, octagons, and stop signs, and an endless amount of shapes. Now, the learning about shapes is called geometry. And one important lesson to learn about the shapes in geometry is perimeter and area. Yes, perimeter and area. These concepts have been used since forever. The Egyptians and Babylons used this kind of stuff for pyramids and for their transportations and canals they used underground. It has evolved to using in architecture and landscaping for art and, well, for math. Today, I want to focus on three shapes: the square, the triangle, and the trapezoid. Why trapezoid, you might ask? Well, you'll soon find out. Anyways, perimeter is also known as the distance around a two-dimensional shape. You can think about it as taking a string or paper clips and see how many are used to fill the shape, and then compare it to a ruler. Finding perimeter is easy peasy for these three shapes. You are pretty much just adding all the sides together. Say this here, you see the sides is 4 centimeters. By the definition of a square, all the sides are the same length. So if you take 4 plus 4 plus 4 plus 4 and get 16 centimeters, then you, my friend, have the perimeter of the square. This also works for the triangle and trapezoid. Now, area. It is the amount of space within a two-dimensional space. You can think of this as how many 1 by 1 squares you can use to cover shape without any spaces or overlaps. There are a few formulas that can help you solve these areas of these shapes. First, you have the typical base times height, which are used for squares, rectangles, parallelograms, etc. So for this shape, base is 4 and the height is 2, which makes the area 8 inches squared. And don't forget the squared, which means the reason why you have to have squared centimeters is because it is measuring by 1 by 1 square units. Now for the triangle. The area of the triangle is half base times height. And you can think of the triangle as half of a square, rectangle, and so on. So for this triangle, if the base is 3 and the height is 4, the area would be 10 centimeters squared. Now, for the trapezoid. The reason why I chose the trapezoid is because it has, well, a square and triangles in it. The area formula for a trapezoid is half of the base 1 plus base 2 times the height. Now, where did this formula come from? Well, if you think about it, if you take this trapezoid and make an exact replica and rotate it 180 degrees, you have yourself a parallelogram. As I said earlier, the area of a parallelogram is base times height. So you have then multiply the base times the height and then divide it by 2 to get the original trapezoid. Well, that's all I have for now. Until next time, we can tackle the circle. Dun 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 dun.